Well, good afternoon, everyone, and welcome to today's webinar where we're going to take a closer look at different phases of or throughout the product development process where the Creo suite can have an impact. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And taking us through this presentation and journey today is Jerry Rather. And Jerry is a sales enablement program manager for CAD with PTC, and he's been with PTC for 30 years. And I think he started when he was about 8 years old. Uh, Looking at him, he's definitely got the fountain of youth. Um, so we won't be sharing those tips today, but he's seen a lot, and he's seen the evolution of Creo throughout that time. So we're going to get a lot of really good insight to, hopefully helping you think about your current product development process and where you can improve and, take some good information from this and basically hopefully just get better. So Jerry, you have control. We see your screen.
All right, thank you, Rob, and
Thank you.
Thanks everyone for joining. So, in my role now at PTC, I've been doing sales enablement since about 2001. So, where in how I use this presentation is really to introduce new sales reps and even sales reps who've been here for a long time to Creo, to illustrate how Creo streamlines the product development process and really defines and powers a digital thread. So I've only got about 9 slides. I want to focus more on actually showing you that design scenario where we start with concept design, we move to more detailed design, we do some refinement with simulation and analysis, go to manufacturing, and then, we implement that late stage change that frequently and unfortunately occurs for all of us. So rather than talk about it, let's jump right into it. So the first thing I do, and it's a good one for everybody, like, what is Creo? And the typical response I get from people is that Creo is a design solution. It helps customers bring innovative products to market, to decrease time to market and do all these great things. And it's a pretty decent explanation, but it's only a partial explanation. So what Creo really is an entire comprehensive suite of integral solutions. We support everything from concept design to engineering and detail design, simulation and analysis, manufacturing, and even communications. So the great thing is we've got all these tools. They're all very tightly integrated, which means when I make that change, everything is going to update predictably. So we used to say years and years ago, it's this concept of a change made anywhere updates everywhere. So that's the reason to have one integral suite of tools. If I don't have one suite of tools, I'm probably using some third-party solutions throughout the product development process. And there's a lot of reasons companies go there, right? A lot of times people are hired, they're familiar with a particular tool. Maybe they came from a manufacturing and they like using Chemex. Maybe they use Patran or Nastran for analysis. Maybe you as a company, you acquired other companies. So with that, you acquired their tools. So a lot of different reasons why this happens, but it's pretty common for everybody. So if we think about the use of third-party tools, you got to think about how you break that digital thread. So a lot of the focus is going to be how Creo, again, maintains and powers that digital thread. If we have those third-party tools, again, one way to look at it is if I have a third-party tool, I have disconnected products. Right? If I'm using Creo to design and I need to send the analyst a step file, an IGES file, or whatever format so he can do analysis, we've got disconnected products, right? And because we have disconnected products, I can't really automate and streamline anything, because if I make a change to the design, well, I need to export another IGES model, step file, or whatever it is, so they can update, maybe do their rework and redo everything they've already done, because, from their system, it's looking at the model like it's a different model. So again, you have disconnected products. Disconnected products means I have a disconnected process, right? Because what I'd love to do is make a change to the design and have that change automatically update. Well, we don't have that because, again, we broke the digital thread. So now we have a disconnected process, which makes it very difficult and manual to make all of those updates when these design changes happen. So it's difficult to deliver those quality products on time and under budget and various other reasons. So disconnected products, disconnected processes. We've also got disconnected communications. So if I am needing to, let's say, understand where that design is used downstream, it's no longer automated, right? Now I need to be aware when I made the change, did the suppliers, did the outsourced partner who's doing some analysis, do they know that they're working with an old version of the model? So we better have everything really in line so we can communicate when those changes happen, because again, that communication is disconnected. It's completely manual. We can do some things to improve it, but it's not a good thing. So again, third-party tools, break the digital thread. There's no way we can streamline the product development process for all those reasons and more. So the way we used to introduce, and this is back in the days, right? So back in the 90s, we did a lot of demos. We were doing 5 demos a day, and it's still the same today. What we need to know and what companies need to know is how are we doing today? So we would always go in and we'd whiteboard it. We'd say, hey, tell me, what are you guys doing for concept design? What tools are you using and how is that working? And then we'd map out what kind of tools they're using. Okay, when you're done with concept, what's the next step? And they say, well, then we give it to engineering. Okay, great. So what tools are you using there? And again, it could be a mix of solutions. It could be one, who knows, right? Depending upon the customer. All right, now you're done. You've completed that design. What's your next step? Well, if we have an analysis group or we're developing or creating those types of products that require it, we're going to send it to the analysis team or maybe outsource that work. All right, and when you're done with that, now that we know we've got a product that works, now we're going to maybe throw it over the wall and give it to these guys in manufacturing. And then it's like, what tools are they using? And when you're done with that, hopefully we're going to kick off everybody creating these other deliverables. And it could be shop floor instructions. It could be manufacturing process documentation, all these things. And then we said, what happens when there's a change? And that's when everybody said, oh, yeah. We go back to design and now we got to implement that change, right? And it depends how complicated the change is. But if we made a major change to the design, we probably need to redo the analysis, right? And then if we're sure that that design change still works, right? The model's still going to function as it's supposed to. It's still going to, handle the amount of stress that it's going to be subject to. Now we know we can give it back to these guys in manufacturing, and they're going to do a lot of rework. And again, depending upon the change, how much rework, it all depends, right? And then these guys doing documentation, they need to do all the updates as well. So this process was really it's still what a lot of customers do, but it's this idea of, listen, when we're designing engineering products, we're going to have to implement these changes. So how well can we implement the change and have that change trickle down and update all of those deliverables? Because what I'm showing here is just a handful, right? There's many other deliverables, but it just snowballs. So the idea of Creo is, if we can do more of a consolidation, right? Do more Creo throughout the process. Now we're going to enable you to streamline that product development process and really power that whole idea or concept of the digital thread. I make a change updates everywhere. So what does that allow us to do? Because everything is integrated, right? One common model, one common source of truth. I make a change to the design part. The guy doing the analysis, he simply regenerates the model, right? All of those constraints and loads, wherever they're placed, are going to update. Now, there's not everything, I shouldn't say, because if I deleted one of these support structures and there was a tool path or a load placed on that, now when I go to analysis or when that guy regenerates, it says, hey, you've got a load on this particular surface, but it's no longer there. So then we go in, we simply redefine or maybe delete whatever that load is because what it's referencing no longer exists. Same thing with manufacturing, but ideally, when I make a change, it updates everywhere. The way I always explain Creo to anybody is it's like the government, right? Everything has a unique ID. It doesn't matter if it's a point entity, a corner, an edge of something, a surface. What Creo does really well is track all of those references. So it knows every parent and child reference. So when I make a change, everything is going to update predictably because we handle that very well, which is why we make very powerful, predictable, robust changes. And when we do make a change and it impacts geometry downstream, so child geometry, it's going to tell me exactly why that feature needs to be redefined. Not only does it tell me, but it's going to show me what features it's missing. And I'm going to show you this as well. But again, here's the whole story. If we can do this, we can maintain that digital thread, we can streamline the product development process, we're going to really compress time to market, right? So we're going to get to market faster, maybe do more within the same allotted amount of time, take on more jobs, whatever. But that's because we're streamlining the process and we do hold that digital thread. So if we can maintain the digital thread and get the benefits of these automatic updates, we're going to be more productive and we're going to focus on quality and all these things we need to do to be more competitive, focus on innovation, focus on getting products to market faster than our competitors. So with that, I like to just show it. You know, I can talk forever, but I'd rather show you this whole scenario. So what we're going to do is start with generative design. So when we came out, we bought the company Frustum back in, I think it was December of 2019. So we did a lot with the development. We didn't release it. And Brian Thompson, who runs all of development, says, we're not releasing any products until they're 100% integrated. So when we came out, the good thing is after we bought, I'm sure they were working on multi-body design, but when we finally did the full integration, we take full advantage of multi-body design for our generative design. We also use it when we think about 3D printing, lattice creation. We use it in analysis. We use it in many different tools. So if you're not familiar with multi-body, it's the ability to work with a part, but we're almost working with it like it's an assembly. So here's a body. And again, this is just my setup for generative. So that's what I'm calling the envelope. But I can define different features that reference each other. So when you're designing a complex part, multi-body design makes it really, really much easier to do. Before multi-body, I'd probably use top-down design and skeletons to capture those references and use that to drive the change. But with multi-body, again, I'm able to work at a part level, but almost treat it like an assembly. So it works really well. So all we do for generative, this is basically the setup, right? I got some simple features, and those features are what make up these different bodies. So from here, I simply go up to my applications and let's go into generative. So generative, like all of our solutions, the reality is if you work left to right, it's pretty easy to learn because that's pretty much the progression of things I need to do. Here you can see it's giving me some warnings that says, hey, you haven't given me any information to get started. So if I look at those cues and I do what I need to do, where's my starting geometry? That's going to be right here, right? And that changes to translucent. What's your preserved geometry? I'm going to grab that body and those. So preserved geometry in generative is typically any mounting areas, right? If it's a mounting area on the part, I need to make sure I have geometry to mount. It could be a plate, it could be an angle, it could be whatever, but I need to have material here so I can mount it, attach it, or do whatever. Then we can do exclude. So exclude geometry, we don't really need to do because I could put it in the envelope. The benefit of using it is I can decide whether or not I want to use it. If I want to have the preserve, I can do it. I can have that geometry. I don't need to do anything. I can just leave it blank. right? I can delete it, do whatever. But in this instance, I've got my starting volume, and I'm going to say in this area, maybe there's another part that's in here or whatever, and it's going to interfere. So use this volume, but don't go in the exclude area region. So the next step, again, I'm just going right down the list. So what have I got? What are my loads? What are my constraints? So the constraints, I'm going to simply go up here and say it's fixed back here. I'm going to grab those faces, and now it's fixed. I got some loads I need to define. So I'm going to say, let's put a force on the bottom of those two. It's going to be a directional force in the Y direction at 3,500 newtons. So that quickly, I've defined it. The nice thing about generative, I've got one load set. You can create multiple. So I'm going to say, hey, duplicate that load set. Let's make this one active now. So I'm basically copying over everything from the previous, and you can create a new one up here by saying add a load case as well. The constraint's the same, but the load here is what I want to change. So I'm going to redefine that and say for that one, I'm actually going to reference that surface instead, and it's not going to be in that direction. It's going to be in the X at a negative 5,000. So we're going to add one more force load, which is going to be on this other one over here, and that's going to be directional again in the X direction, 5,000. So that quickly, I've got two load sets. I've got the starting geometry defined. Now I'm going to set my criteria. So it says, hey, what do you want to do with this? You want to maximize stiffness? You want to minimize mass? We're going to stick with stiffness. And I'm going to say, let's try to make the strongest yet lightest part. So I'm going to say, if possible, use 35% of the volume, right? And just for the heck of it, let's say linear extrude, because I want to machine this maybe 3-axis. So it says, okay, great. What are you going to reference? That's my direction. At that, I've got the material defined already. Simply say, okay, and we're going to optimize. So here, it's basically looking at all of the constraints I gave it, the loads, the material, whatever manufacturing constraints, and it shows me how I could or maybe should create the part differently. So used in early conceptual design, it really gives me an idea of how to maybe think differently about creating a part. Because unfortunately today, and I came from Ford, right? What did we do? We took an old part and we tweaked it for the next version of whatever model vehicle it was. So did we really do any innovation? Did we create a better part? We really didn't. 98% of it was the old part. All we did was tweak it. So with generative, it really speeds, if you want to look at it, it speeds time to innovation, right? A lot of work would go into designing a new part. Here, I'm going to use this to say, how could I do it differently? So there's one option. And we're going to do this and say, let's duplicate that as well. But on this next one, let's say maybe I want maybe more of an organic type of shape. So what I'm going to do is delete that constraint and say, show me what you can do. I don't care if you web it, however you want to do it, but show me how to create that part. What do? I simply optimize once again. So again, all it's doing is looking at the setup geometry. It knows the loads, it knows the material, it knows whatever manufacturing constraints. And if there's stress, it knows I need material to handle the stress. So that quickly, we went through 2 different iterations. Now, if you really want to explore a large number of options, you can use GDX, which I would send this to the cloud. And then I'm solving locally. When I use GDX, I'm solving in the cloud, but I can pick numerous materials. I can have different load cases. I can have many different design scenarios. So I specify what I want to run, and it's going to spit out, it could be hundreds, whatever, how many options you want to actually solve for. And the great thing is with that tool, not only does it solve simultaneously for all those different options, but then it gives me tools to go in and evaluate the best of the bunch. So think about if you got 100 different options, yeah, that's great. but how do I pick the best one out of 100? So there's a lot of different tools that allow you to go through and look at and compare all of them as I make adjustments to what's important. Maybe it's factor of safety. Maybe I want to focus on the weight and everything updates. Then when I get down to maybe my top 3, you can do a side-by-side comparison. So really a great tool. Again, if you want to do enormous amounts of these in terms of how many you want to look at and explore, that would be a good option as well. That's GDX. But again, here I'm just using GTO, which is our generative. I'm solving locally. So this is where most companies, when they see it, they're like, okay, I guess I understand what generative does. How do I use this? Right? That's not the way our design process works. So what do I do now? Do I have to 3D print everything? That's the immediate question we always get. So if you need a prototype tomorrow, sure, I could directly 3D print the faceted model. We also have the option to do a reconstruct. Now, reconstruct looks cool, but it's not feasible because if you look at this, would you actually want to produce this? I got a flat there, I got a divot, I got crazy stuff going on. This would be very, very costly to machine to get a tool in there. I don't even know if it's possible, right? And if I'm mass producing this, I'm never going to make money 3D printing. So the better option is to say, maybe I'm going to use this as a concept model, right? And that's how companies are looking at generative today, right? Because again, it doesn't make sense to go directly to 3D print. I'm going to take this and then I'm going to say, maybe I'm going to rebuild it. So the way that would work, I can create that tessellated model, and then I'm going to simply use that in whatever application, maybe in Creo, maybe in Freestyle, but whatever. So let me show you that. We'll assume that we're done here and we want to take this and now reverse engineer it. So let's go from there. And now I'll show you how you would possibly do that. So one way to do it is using Freestyle. So Freestyle is subdivisional modeling. It's really a cool tool in that you want to create some very complex surfaces, but you don't want to go through creating the curves, manually creating the surfaces, manually worrying about all the connections. Freestyle, I'm basically working with a primitive shape. So it's very easy. Notice that's the import I did. That's from GTO, the output. And here's my Freestyle geometry. Let's go in and redefine that. So the way Freestyle works, I'm basically manipulating primitive shapes. I can take these things and do whatever I want. So if I just want to take it and match it, and again, the first time I did this, I think it took maybe an hour and a half to redesign it. But there's a lot of things you can do. Like if you look at this here, I don't like the fact that, I'd like to have this whole thing planar, right? It kind of matches the shape there too. So to do that, I'm just going to hold down the shift key. I can pick that and simply drag and look at it here, turn on our datum plane. I'm going to hit right mouse button. I'm going to say, make it planar to that plane. Right. So very quickly, I can take that and I can do whatever I need to do. So here's where we can do any number of tweaks. I can grab individual vertices. I can grab edges. I can grab the faces. If I want to go and do something different, it really doesn't matter. So I can grow that. I can tweak it, pull it, do whatever I need to do. Very quick. And it really is pretty easy to take that geometry and just use that facet geometry is basically like an overlay. So it works pretty quick, pretty easy. I like working in the box mode a lot of times. To me, it's easy to see all of the different faces, vertices. So like we need to make that little support. So let's grab the face. We're going to grab this other face here. Right? And then we're simply going to join those. So just quickly to show, you could see how generative could be, or not generative, but Freestyle could be used to easily go through, take what was really a complex, relatively ugly looking shape and turn it into something that is a good looking piece of geometry. And more importantly, it's a piece of geometry that I could cost effectively machine and reproduce, right? So we're going to hide that. Let's turn off our datum planes. Now you can see, again, we've got nice, clean geometry. and definitely something that I could machine, probably with 3-axis, getting at it from both sides, right? So there's one option. Again, that's using freestyle, but I also use some Creo, right? There's my freestyle, then I solidify and I do these other things, right? But the reality is it's pretty quick, it's pretty easy. One way to maybe reverse engineer. What I'd probably do, and my tendency would be to recreate a parametric model, right? So something that everything's got a dimension, I can go ahead and tweak, I can modify, I can do whatever I want, but I want those dimensions a lot of times so I can do that refinement I'm looking for. Maybe I'm going to use it with behavioral modeling. I'm going to do some goal solving, who knows? So the first thing we would do is obviously look at this and say, okay, I didn't reproduce exactly what came from generative. So do I know that the part's actually going to work? The material has a max stress of 240 megapascal. So the first thing I want to do is go into live simulation. This is our partnership with ANSYS. So I go into simulate. Immediately it says, hey, you haven't given me enough information. I'm like, okay, I get that. So what we're going to do is just define those things. So we're going to go into our constraints. I want these areas to be fixed. Notice the way I'm doing this, the same way I defined it in generative. So when you're using simulate, ANSYS simulation, simulation live, generative design, anything else, the same way I define loads constraints, the same way I do it in every tool. So everything is very consistent, which makes it easy for existing users to go ahead and learn. Then we've got our loads. We're just going to use that load on the bottom here, and let's grab the other one. And that's going to be in the Y. Let's go directional here at 3,500 again. So that quick, we've got the analysis defined. I simply say simulate. Now the goal of Simulation Live is it's a tool meant for somebody like me. Primary role is engineering and design. I don't want to wait. What I want to know is, hey, I'm designing a part. If I make a change, did that change help or hurt me? So here I can see I'm at 227. Again, the aluminum alloy I'm using has got a max stress of 240. So the first thing I would do and look at is say, what can I change, right? I don't have much stress through here. Main stress is right in the beam. So I could begin tweaking and do some stuff, right? But what I'm going to do is maybe use behavioral modeling. So to do or use behavioral modeling, all I need is a measure. So I'm going to say, give me the max stress of this beam right here, right? So now I got the max stress. And really what I'm looking for, I just need a measure. That's all I need to do behavioral modeling. Now that I have a measure, I can go over here to analysis, and we can do many things. I could do a feasibility optimization, a design study, a sensitivity analysis. So when we do a feasibility optimization, I basically define a goal that says, I want the stress to be less than 180, and here's the variables I want to use. Tell me what the design should be and what those variables should be to meet that goal or objective. I'm pretty confident if I change the size, that's going to work. So we're just going to do a sensitivity analysis. And I'm going to say, that's my goal. I want to lower that. So my parameter, and notice it already knows it because I only have one measure that exists in this part right there. So if I had multiple, I'd have a list. So I'm going to say, I want to take that measure of stress. And, you know, the dimension I want to use, it is in the actual height of the main beam. So right here, it's currently at 22.5. But what would happen if I went to 28? So that quickly, I'm going to say, I don't know. Is it worth me working with that? Is that main beam altering the height? Is that going to get me what I want? Because sometimes maybe it looks like we eliminated the stress and maybe all we did is move it to another area. So when we're using behavioral modeling, I can really easily go in and say, how is this stress, or how sensitive is that variable to my design goal, which is again, lowering stress. So I could do this manually, but I could take a long, long time doing it. And when you get very complicated models, I could have many different variables. And I can solve for multi-objective design studies. So I could say I want my stress less than 180, and I want my mass less than, I don't know, 200 grams. And then I simply say run, and behavioral modeling is going to tell me exactly what needs to happen to achieve those objectives. And if they're not achievable, it's going to tell me that too. And maybe I'll make a change that exceeds the limit of the geometry. So if I moved it past that 28 and 30, it's going to say, hey, I can't regenerate for all of those iterations, but it's going to tell me that as well. So here very quickly, that's where we are to begin, 215. And if I go to 28, look what it's telling me. I can go down to 141. So great. Now I know that's a good variable for me to work with. So I'm going to simply go in to the height of that main beam. We're going to say modify. And I always used, even years and years ago, I liked using a graph. And it's just a cool piece of geometry, and that you can take a sweep, but you can vary anything. I could have multiple graphs that define the shape. I can alter this graph to look like anything I want. I can use a calculation to make it do all kinds of crazy things. And as it sweeps along, it's simply going to reference that graph for the height, which is what I did for the width of the main beams, I'm calling them, and also the outer. So here we're good. If we go to live simulation and do this, right? Very quickly, we're going to have our updates, and now we can see where we're at. So now we went down to 141 by simply making that change. So here's where we'll kind of make the assumption and say, let's say we've tweaked this thing, and we're going to do some more tweaks because I really don't think I need either one of those. And there's a good possibility I don't need the outer one as well. But let's say we've been doing this for a while and we've got a model and we're good with that model. People ask, where do I use live simulation and where do I use ANSYS simulation? So this is live, it updates as I'm working. When we go to ANSYS simulation, the whole idea is we want high fidelity. So it's using ANSYS solvers. It's actually creating the mesh that simulation live does not create, but allows me to do some other things. I've got different options for constraints and loads. But notice when I come over here, it knows, it says, hey, you haven't updated this, but the loads are already defined from simulation live. It's just saying in here, you haven't run it. So when I run, the main difference is going to be it's using ANSYS solvers running in Creo, but again, it's not going to be, you know, instant feedback like CSL. So this is going to take a little bit more time. But what I'm going to show you is this idea that a lot of people say, well, we're not using live simulation because it's not as accurate. So here we're looking at 141 megapascal on this main beam. Once this computes and we get the calculation, I'm going to show you on the same model, the same constraints, same everything, you're typically within like 2 to 3%. But still, as I'm designing, I'm going to use live simulation because I want those results immediately. I don't want to have to keep going back and forth, right? So now we look at our von Mises stress. And again, look at the max there, 158. Right? 156. And this is just our legend. So what I'm going to do is I'm going to create another probe over here. Not displacement, von Mises. We're going to say max, but we're going to put it on this beam. Now I'm going to, for some reason, that doesn't update, but what I've found I got to do is I'm going to rerun, and I'm going to check with the product manager on this, but I think that should update automatically. But basically, once I say run again, it's, I don't know if it needs to look at the stress, but look at the answers, 141, 144. So we're off by roughly 3, which is maybe 2%. So anyone who says we don't use CSL because it's not accurate, I don't know. I think that's pretty accurate. So let's say now we're done. We validated the model. We know it's going to work. We know it's going to handle the stress. What's the next step? So a couple of things, right? Maybe before I send it to manufacturing, maybe one of you, or maybe you're a manager, maybe you're a program manager, maybe you're the head of engineering. You don't necessarily use CAD, but I want to send the model to you. So I could use our AR design share. If I go into tools, I go into target. It's going to place that thing mark for me. I can say, okay. Now I've got that. I can publish the model. It's going to have me log in, and anybody with a PTC ID has this capability. So I'm going to log in, right? Here's my password. Say okay. And that quickly, I'm going to put it personal. There's two different areas. If I use this one, you have more capabilities to remove people and do some other things, but just for the sake of the demo, we're going to put it in this one here. Select the target there. So that quickly, I say, okay, and it's going to publish that. So the whole idea is maybe I want, or maybe I have a design review tomorrow. So I know a lot of people in that design review don't have access to Creo or don't know how to use it. So make sure everybody's prepped for the tomorrow's design review. I'm going to go ahead and send that to people. So all I got to do is take this and say, hey, let's share it with whoever. So I can add any kind of email, right? We're going to copy this link here and we can simply do that. Now you get an email and you're good to go. Everybody's going to get a notification. Now on your phone, you can scan the thing mark and you can be spinning around that geometry. So when we meet tomorrow, you can say, hey, Jerry, I like this. I don't like that or whatever. But again, just one more tool, part of the suite. And again, very easy to use. So people have access to this, but I don't know how many people are actually using it. So let's take that. The other thing we might do is maybe go in and create a drawing. So I've got a quick drawing in here. It's kind of boring, so I don't spend a whole lot of time there. You can see it already added the thing mark, but we could do more work here, do whatever we need to do, right? So now we've got a drawing, but what we want to do is kick off manufacturing. So we're going to go into that suite of solutions. So here we are in manufacturing. I've got my work center. I've got the fixture because when I do the simulation, I want to make sure my tool doesn't hit any part of the fixture. I've got the operation defined. I've got our bracket and the actual workpiece. So within manufacturing, again, I know how to use Creo. I just have some different commands, but generally, once you know how to use Creo, you pick up these tools relatively easy. So first thing I want to do is define some manufacturing geometry. Mill window is really nice. I'm going to simply pick a plane, and you can either sketch or grab it here or pick the workpiece. I'm going to define, there's my options, right? Silhouette, sketch, chain. I'm going to define the depth for it. I want the tool to go all the way through, so we're going to put that out to like 35, right? Because my part's like 30, I think. We've got that defined. You can do options. I'm going to choose the option to go outside the window. That way my tool can go outside so it can hit the perimeter of it or the profile. So now we have that defined. So we can go in and start to define our milling sequences. So here we can do a roughing sequence. I'm going to go ahead and grab my tool. So we got a 10 millimeter bullnose mill. It says you want to grab the parameters associated with that. Sure. And there's a lot we can do with templates. If I have predefined things, I could simply slap that in here and give it the other mill window, all the parameters, all the tooling, everything is going to come over with it. So I'm kind of going to automate a lot of my machining. I'm going to go ahead and change the coordinate system. So the Z is in the direction of plunge. Then I'm going to pick my mill window. We can go into the parameters, and I'm going to say for that 10, let's make the step over 4. I'm going to leave 0.5 stock allowance. And just for the sake of demo, we're going to machine faster. So I'm going to do a step depth of 3. The clearance is going to be using or referencing that plane. So let's just push it out here, maybe to like 15. So that quickly, we've got that done, and we've got our first roughing sequence. So again, let's slow it down maybe. Right. So that quick, we've got the first NC sequence. If we want to go ahead and simulate that, we can go in and do that. So this is where we're using capabilities from ModuleWorks. We use ModuleWorks for the high-speed machining and the simulation and verification of the toolpaths. So what it allows us to do is go in, and now just like we use simulate to verify the model is going to work with the loads and stresses. I typically want to play the simulation so I can look at how that toolpath is working and what the results are, and maybe figure out what I want to change to maybe optimize the toolpath, right? Because I've got a retract plane out here at 16. I'm doing a lot of air cutting. Probably not ideal if I'm creating a whole bunch of these. So you can do a lot with your tool paths to do some further refinements to optimize and speed the machining of it. But again, just to show you, let's do that. Right, let's look at it from this side. All right, so the nice thing about that mill window, again, all it does is find the part. I can make crazy changes to the part, but because I didn't pick any specific entity, that toolpath is always going to update, very robust, because it knows I've got my work piece and it just finds the part. So there's the first one. We can define more. It really doesn't matter, right? I do multiple roughing, then I do my refinement and do some other things. But for the sake of a demo, this is where we say, oh, now what, right? Maybe this is where somebody says, hey, Jerry, I get what you did. You increased the size of the main beam, but because you added weight, maybe you need to take some weight out. So let me first go in here and I'm going to hide this stuff there. So now I know that I added some weight to it. So now I got to think about how could I maybe remove some. So if we turn on our live simulation once again, I can see what areas of the model have stress, right? Obviously, I got nothing through here, right? On the outside, I could probably delete that, maybe make this a little thicker. But for now, let's just think about removing the support. So we're at, what, 141 here. There's our legend 146. If we look at our features, there's that one. Here we are there. I'm going to say delete. And this is where what we do, PTC with Creo, we don't allow you to make a change that causes other dependent features to not be explicitly defined. So there's other software solutions. For instance, I'm sitting on a chair. You can delete the chair and they'd be like, okay, you can leave that feature hanging. But that's why models eventually start to be a little bit corrupt, because you got features in them that are not explicitly defined. Within Creo, we don't allow you to do that, which people might say, well, it's hard to use. Why? Because we don't allow you to have bad modeling best practices. That doesn't make sense. So what Creo does really well is it says, hey, if you make that change, you've got quite a few dependent features. What are you going to do? I either take the option to delete them, or I'm going to say suspend, and I'm going to look at each one and figure out why it's no longer valid. We got the notification center. Here's where you can easily click through and it tells you exactly why and what feature and all that information. Over here, I can see what doesn't work, what's failed. So I'm going to simply go in and say, let's edit that, right? If I look at the details, it says, hey, this doesn't make sense, right? Highlights in the model up here. Well, that makes perfect sense to me. I don't have that support, so I really don't need or shouldn't have a draft defined on something that doesn't exist. So that quickly, it points it out. It tells me exactly what doesn't make sense. And I just simply go one by one and say, okay, why didn't that work? So that round set doesn't work for obvious reasons. That doesn't exist. So let's just delete it. Right, as we go through, we'll get right to the part relatively quick, right? Those edges don't exist. So it's simply telling me, hey, your feature doesn't make sense, right? Because those things don't exist. Let's take this last one here. We got a couple more. You can see why that doesn't work. I had 2 segments, but I used to have the support. So I'm going to say get rid of those as well. Say, okay. Oh, what I should have done. Now I missed around, right? Okay, we missed around there. Let's look at which one that was. I think it was that one. Yep, let's add that guy. There we go. So now we made a change, right? What happened to our stress? Let's see where we're at. So we're at 143. Okay, that's good. Maybe because I removed it, maybe we changed the placement of this one. So if we grab that. Let's do a quick modify on it. We'll do a quick edit and let's move that down. Maybe make it like 38, right? So that quick, we've got our change. Now we look at our stress. We're still pretty good. We're at 143 after that change, 143 and change, right? So we're still good. Here's where, again, because we've maintained the digital thread, now we know we're good. And again, would I do applications and do ANSYS simulation to do the high fidelity? I could, right? I could maybe do further analysis with guys who really know what they're doing in analysis. But for me as an engineer, I know I've got a decent part because based on the loading conditions and the constraints and using analysis, I know I've got a part that's going to work. So here we're all set. So now, of course, it's all the updates, right? Where's my drawing, right? If I open up my drawing, again, the great thing about Creo, hey, I made changes, they're all updated. Don't need to make any changes. I might go back, do some more detailing, but all the changes are there. When we go into manufacturing, all I got to do is simply regenerate, recompute that CL data, and our toolpath is going to be all up to date. So now if we play that roughing sequence, once again, we're going to have that update based on the new geometry by simply doing a regeneration. So that's kind of it in a nutshell, but what I wanted to show, and if you think about it, we started out using generative design, right? From generative in a short amount of time, we jumped in, we did a little bit of freestyle. Let's show you how you can reverse engineer using freestyle. Then we jumped into some Creo, made some changes. We did some refinements using live simulation and ANSYS simulation to verify and validate the integrity of the model. We did a little bit of AR design chair to maybe get some feedback from other experts in the company, did the machining, and there we are. So again, I like to show this, especially to, new sellers coming on board, and even more of the sellers that have been around, but maybe they're selling other solutions in the PTC solution suite. So for them to get a view and understanding of what Creo is, I think this demo does a decent job of that. But again, if you think about it, it's one suite of solutions. It's not just design. It's about having a solution to do conceptual design, detailed design, analysis and simulation, manufacturing, even the communications piece. So if there's any questions at this point, Rob, I'd be happy to stay on the line and answer them. I think the next time we get together, we're going to focus more on generative design and all the different workflows and how people use it. I kind of alluded to that some today, but we'll go in more detail. So,
Yes,
Rob?
Jerry, this was absolutely fantastic because I know it's a little bit of a longer webinar, but you're going through the entire product development process, and we're showing where up front you can become more efficient and how these tools can not only just help you think outside of the box, but basically do the thinking for you.
Yeah.
So yeah, it's pretty awesome. So anyway, yes, we are going to have another webinar in July on the 17th, I believe. Is that the right date?
Yep.
No, the 18th.
Yeah, I think so.
July 18th, Thursday. So we'll get more into generative design as well. But also, like, what I really like, Jerry, is that you not only showed how to use these tools, but also from a machining standpoint, because a lot of times it can be a sticker when you're thinking, well, yeah, if I could design something, well, if I could design it, how am I going to manufacture it?
Right.
I think you showed some good things here.
Yeah, appreciate it, Rob. Yeah, I think this demo, again, because it shows the value, right? When you have a connected tool and you maintain that digital thread, you get more value out of it when you have those automatic updates, right? As soon as I bring in a third-party tool, I can't do what I'm doing now. Do we have any questions, Rob?
Yep. No, there are no questions.
Okay,
So we're gonna end the webinar here, and I'm gonna have a recording sent out to the link to the recording sent out to everybody by sometime tomorrow. This way you can watch the webinar at your leisure. And if you have any questions that you think of later, or if you want to have a one-on-one demonstration of anything that you saw here today, you can contact us at info at 3hti.com, or you can just reply to the email invitations that were sent to you. So Jerry, once again, thank you very much for this overview. This was great, very informative, very direct, a lot of good stuff here.
Thank you, Rob. I appreciate it.
Yeah, and we'll do this again in a couple weeks.
Yep.
All right, thanks, Jerry. Thanks, everyone.
So you're welcome. Bye, all.